Breaking news from the University of Toronto Astronomy 201 department regarding the changing brightness of our favorite supergiant Betelgeuse. Recently, the astronomers have observed that Betelgeuse has finally stopped changing its brightness unpredictably. Its brightness started to decrease since December last year and is currently sitting at around 36% of its usual brightness. Betelgeuse is a supergiant star that is 900 times bigger than the Sun, and it is located in the constellation Orion, which is 722 light years away. Even though it has a red color right now, it is used to be a M-type star with a whitish blue color. As shown on the HR diagram, before entering its supergiant phase, Betelgeuse is located at the top left area, which indicates that it has high surface temperature and high luminosity. In order to understand why Betelgeuse is changing its color, we need to understand the life cycle of the star. As shown in this graph, there are two main pathways for a star to live its life, and the determining factor is its mass. For simplicity, the Sun would go through all the phases appear on the top row, start from a stellar nebula, and the dust and the remains combine and merge together by the pressure of gravity to eventually form an average main sequence star. Not too massive, not too hot, just average in temperature and mass. Then, it will inflate after it is almost done transforming all this hydrogen into helium and become a red giant. Then, the Sun red giant will explode and form a nebula with its death core left, which is known as the white dwarf. On the other hand, we can see the more massive stars at the bottom row have a rather different journey. Betelgeuse will experience all the phases at the bottom row from forming the star from a nebula, then do what it has to do, which is to be a massive star and burn its fuel and just to be the brightest in the sky to outshine everyone else. Then it will become a red supergiant, which is the phase it is at right now. After that, it will explode and cause a supernova and end with one of the two results, a neutron star or a black hole. The Sun is known as a mid-age main sequence star that has another 5 billion years to live, and in its current phase before transforming into a giant, whereas Betelgeuse has already transformed into its giant phase, and this red supergiant is a variable star, which means it can change its brightness over time, and it's common for it to happen in this type of star. It is predicted to explode in 100,000 years, and when it explodes, it will cause a spectacular supernova and will potentially become a black hole. However, Earth is in a safe distance away from any possible damage that Betelgeuse could cause. How Betelgeuse is behaving right now is very important because it lets astronomers and scientists better study and understand the life cycle of a star. The scientists can prove or disprove some theories since it is odd that a star has dropped its brightness to this faint over such a short period of time. One theory by a research team from the Australian National University is led by D. Mertlin Joyce conducted analysis by using evolutionary, hydromatic, and seismic modeling and conducted that the changing of its brightness of Betelgeuse is caused by the stellar pulsations because the star is burning helium in its core. Another theory suggested by a group of researchers based in Kenichi Nomoto at Calvo Institute for Physics and Mathematics of the universe says that despite the star is in its early stage of having helium fusing its core, the smaller brightness variations of the star were driven by pulsations and the dimming only occurred due to a dust cloud. The scientists expect to see that the star will increase its brightness in the next couple of weeks, and if it doesn't, then I don't know, all the bets are off, said Guanyan. This is Mel with AST201 News.